what are all being incorporated in the syllabus. The total syllabus was divided into 6 units. Unit 1 is trying to give you some information on definitions and the robo necessity, what are all the advantages and disadvantages, the basic components associated with them, and what are all the types of robo joints, and how many number of degrees of freedom that are associated with a particular type of configuration in the robo. Coming to the configuration, it might fall under Cartesian type, cylindrical type, spherical type, articulated type, scara type, and there will be different work volume pattern maybe that depends on a particular type of configuration. So work volume is different for different configurations. And if you want to cover a particular type of work volume, what type of configuration is recommended, that you will understand under this particular category. Then after understanding all this, we should have an idea on the robo specifications, how exactly a robo is going to be specified for a particular application. Maybe at that level, one industry specification sheet also will be shown, and altogether the list of specifications what are all being quoted have been showed here. Say load carrying capacity, reach, stroke, speed of motion, speed of response, stability, repeatability, resolution, and accuracy. All these things are very, very important aspects. If you have a particular load for which you need to design a robo, and you should state that what is the reach, maybe within your work volume, what are all the ways in which it has to be moved, maybe with what speed, and what speed of response, whether your movement target can be repeatedly achievable or not, with what accuracy and resolution that is possible for us to. All these informations are going to be dealt under Unit 1. Coming to the Unit 2, various drives and actuators that are all trying to drive the robo. Rather, for achieving different types of motions, we are trying to take the support of different drives and actuators, like hydraulic, pneumatic, electrical, with the support of certain types of motors like stepper motor, brushless motor, servo motor, and comparison among them. In addition to that information, different types of robo grippers are going to be dealt, in particular with various configurations pertaining to mechanical types of grippers are going to be dealt in detail. And coming to the sensors that are required to identify the position, current position, velocity, force, tactile, range, proximity sensors. In addition to that, machine vision and elements of machine vision are going to be used. See, with the support of all these type of sensors, a robo will be able to understand it is at what location, and it will also be able to identify up to what extent it need to, rather the object it need to pick up. So by estimating the distances it need to travel, based on that, maintaining its stability, it is supposed to know or evaluate with what velocity it has to travel, and at the time of picking up, with what force it has to apply on the object it is trying to pick. And in between, if you have got some obstructions, all those things, maybe proximity sensor will try to sense when the movement is on, whether the end effector is close to the object it needs to pick it up or not. Such kinds of informations are going to be dealt under the topics being covered under Unit 2. Then coming to the Unit 3, different types of classifications with respect to servo and non-servo control robots, limited sequence type and point-to-point and continuous motions. In order to achieve them, their requirements, it is in particular are going to be dealt with respect to the application, what application demands what type of motion is going to be dealt. And of course, how an intelligent robot is going to is going to be will also be dealt under that. Then the other major point under Unit 3 is actually trajectory planning. It's going to cover majorly path versus trajectory. There is a small, rather there is a connection between path and the trajectory. Path deals with the way in which the robo end effector need to be moved. Trajectory deals with the path. In addition to that, the time aspects are also going to be added to that. Okay, say in a particular path, the robo end effector is moving through certain points. If it doesn't show the accountability of time, will confine that as a path itself. Say when it is moving across points, maybe point 1, at what time it is going to reach there. Point 2, time. Point 3, time stamp. So if you add across all those points the times, then such a kind of description is going to be referred as trajectory. So all such kinds of informations are going to be dealt under it. And at the time, maybe for describing that particular path or trajectory, we are going to take the support of either giant space scheme or Cartesian space scheme. And giant space scheme is going to be majorly dealt under that. That includes via points, as well as when different points have been stated. In order to have a smooth motion among them, we will try to see the possibility of using cubic polynomial fit for them, and then we shall try to analyze. In addition to them, if we have a Cartesian straight line trajectory, what exactly is the scheme, whether Cartesian space scheme or giant space scheme, how exactly it is going to be handled. With the support of some simple sketches, it's going to be dealt under that unit. Then coming to the 4th unit, it's going to deal with kinematic analysis of robots, wherein, say, when you want to achieve a sort of movement, maybe with the support of giant space or with the support of Cartesian space, both the schemes are very, very important, because when you are trying to move the robo, you are going to give instructions to the joint motors, and you need to attain smooth and continuous motion. For the sake of that, the instruction is going to be given to run the motors in a systematic manner. Whereas when you want to have interaction with the environment, when the robo is moving, that time it is always recommended and better to keep the data in Cartesian format, which means that the data is actually required in both of schemes, means giant space scheme and Cartesian scheme. There is a connectivity between those two. That information can be transformed from one form to the other. Giant space to the Cartesian space transformation has been referred as forward transformation. Reverse is actually being referred as inverse transformation. For the sake of that, we shall try to take the support of homogeneous transformation matrix, and we try to apply the forward and inverse kinematics. In addition to DH representation matrix support also, we are going to take it, because when we come across multiple degrees of freedom, then we should have a generalized method. Okay, that particular method is actually being understood from DH matrix. So this is actually very, very important matrix using which you can extend your analysis for multiple degrees of freedom, because it is easy for us to understand for 2 degrees of freedom and 3 degrees of freedom robot manipulator. Beyond that, if you try to deal, it's not going to be that easy. So handling those situations has become easy with the support of DH matrix. Then any analysis is not going to be complete without taking the support of dynamics, but detailed dynamic analysis is not going to be dealt. What exactly and how exactly the robodynamic aspects are going to be, like forces, torques at various joints, their importances are going to be dealt with the support of a simple sketch. Then coming to the unit 5 and 6, unit 5 is going to give the importance of robo programming types, then of course how exactly the manual setup is and how exactly the lead through programming is going to be, how the textual programming languages are, commands for elementary operations are going to be dealt over there. Okay, then for simple applications we shall try to show you some programming aspects. Okay, there is a laboratory, robotics laboratory in our department. Based on the time available or some additional time is going to be given for you to show you how actually the software tools are working. That also we will introduce. Then coming to the unit 6, it's going to deal with applications majorly related to the industries like material handling. It has got many applications. Machine loading and unloading, assembly and inspection operations, etc. And of course, there is no limit on the applications of robots, but these are the major areas wherein the robots have been put in use in industry. And how exactly they are related to robo work cells are also going to be dealt over there. And at the same time, safety aspects and economic analysis also is going to be dealt. Because when you want to use a robo, that should be rather you are going to invest initial investment is going to be more. So when you are investing more, you should you should be in a position to use it effectively. So in what situations the usage of robo is actually recommendable, all such kinds of aspects are going to be dealt under this particular case. Okay, so this is how your entire syllabus is going to be covered, and these are all the detailed topics under each and every unit. So based on this only, the course objectives and outcomes have been, outcomes are actually, after undergoing this particular course, the areas on which you are going to gain knowledge, and you will be able to analyze on kinematic aspects, and you will also be able to understand how the programming languages are in order to control the robot, as well as for what major applications these robots have been put in use. Only few applications have been shown. Beyond that, there are so many applications which are going out of our imagination. So with this, I'll stop introducing the syllabus. So these are all the various textbooks and some other books which are supposed to be referred. Don't confine yourself only to these books. There are many more areas in open source also. So in addition to these books, try to refer to the open source content and try to gather as much information as possible in addition to the informations whatever we are trying to share. Thank you.